In this exercise, you will learn about inverter. Inverter is a device used to convert DC to AC. In some inverters, pulse width modulation (PWM) is used to provide alternating current power from a DC source to the AC load. By varying the duty cycle of the PWM signal, different patterns of AC signals are achieved. In order to provide AC power with PWM signal, the switching technologies are used in power electronics. Full bridge or half bridge switching arrangement is most common in inverter. Full bridge is also known as H-bridge because of its orientation with respect to load. Full bridge inverter has 4 switches: high side left, high side right, low side left, and low side right. By controlling the switches, the positive, negative, and zero voltage are generated across the load. 4 switching positions are used to get AC voltage across load. It is shown in the above table. All other possibilities with these 4 switches will become short circuit. The switches used are solid-state transistors. Here, MOSFET is used as switching device. The PWM controller is constructed using comparator and triangular waveform. The gate of the upper left MOSFET and lower right MOSFET are directly controlled by the comparator. The other 2 gates are controlled by the inverted signal of comparator. Anti-parallel diode is connected across each switch. These diodes provide path for peak inductive load current when the switch is in off position. When G sub 1 and G sub 3 are triggered by comparator signal, the positive potential is developed across the load. When G sub 2 and G sub 4 are triggered by inverted comparator signal, the negative potential is developed across the load. When G sub 1 and G sub 2 are triggered, zero potential is developed across the load. When G sub 3 and G sub 4 are triggered, zero potential is developed across the load. The switching time of the 4 switches is controlled by an inbuilt timer circuit in PWM controller.